metric ton, 1,000 kilograms. How much energy is required to raise that up? Well, this is where you put it. This is pretty straightforward. Energy is mass is 100 kilograms, 1,000 kilograms. Gravity is 9.8 meters per second squared, and height, that's a difference in elevation, is 10 meters. So 10,000 times 10 is 100,000, but not quite. So it's 98,000. A kilogram meter per second squared. What's that?
Newton.
A newton. A newton meter is what? Joule. Okay. We could have worked this problem another way. Well, if you look at the definitions for energy, a lot of them will have some kind of funny definition, like the ability to do work. Work and energy can be interchangeable with the exception of velocity. Let me ask another thing. How much work would be done to lift this pallet up 10 meters? We have an equation for that, don't we? Work. What's our equation for work?
Distance over time.
Distance over time is velocity. What's work? It's one of these equations you want written down. Yeah, that's it. Say it out louder.
Force over distance?
Not quite. Force times distance. Okay. A lot of times you'll see it as F, where S is the distance. And that force, and it's a dot product, the force and the distance have to be in the same direction. Okay, so we can work this problem the same way. Our work is our force. Force is, in this case, what is the force that you have to push up? What is that force equal to?
1,000 kilograms?
Nope, that's mass times gravity. If you write forces, in this case, the force is actually the weight. And the weight is mass times gravity, right? You see our equations looking just like this. So it's 1,000 kilograms times 9.8 meters per second squared times 10 meters. And we got the same answer. 98,000 joules. So you have to have energy to do work. And if you do work, a lot of times what you're doing is you're converting energy from one form to another. So we didn't say how we were actually raising this thing. This thing might be attached to a motorized winch. You get a winch. So you could ask the question, how much energy is required to lift these bricks? How much energy has to go to that motor to lift this thing up? The answer is, trick question by the way, but I'll warn you, is what is the answer?